Great. Well, thank you all for coming here even after having just eaten lunch. I really appreciate that. I would be taking a nap right now if it were not time for my talk. So I deeply appreciate all of you skipping the nap so that you can listen to me. So this talk is about operating Rails. It's basically meant to serve as an introduction to deployment and operations for newer developers, but it's also the framework that I've come up with for thinking about deploying and operating web applications that I use basically after 20 years of deploying Rails apps to production, right? Like what needs to be covered when you're going to production for the first time, but also what needs to be covered when you're going to production for the 1000th time. And so this is kind of like how I think about things while I am deploying new applications myself today. So before we get into those details, let me introduce myself. I'm André Arko. I'm better known as Indirect on the internet, and my biggest Ruby claim to fame is leading the Bundler and RubyGems open source projects for the last 15 years or so. And more recently, we've been working on a community gem server at gem.coop and new tooling for managing Ruby and managing gems called RV at rv.dev. I built my first Rails application in 2004, and it was trying to get that Rails application off of my laptop so that other people could use it. That sort of started me down the path to madness and also DevOps. It's been a really long journey, and I've learned a lot of things from 20 years of watching Rails apps break in production. And this is basically like me trying to provide the antidote to that in advance. So, setting the scene. An excited Ruby developer follows a Rails tutorial. They create a blog in 15 minutes. Maybe it's a to-do app, I don't know. They walk through the code, the tests, the features. They finish the tutorial. They have a whole Rails application on their laptop that's really cool. They want to show it to other people. And then they realize that they don't have any way to show it to other people, and it's just on their laptop. So then, useful tutorials for deploying things will say maybe you should use Heroku or Fly.io or Render or Railway or DigitalOcean or something. If they're really unhelpful tutorials, they might tell you that this is time to sign up for AWS or Google Cloud or maybe Azure. And no matter what service they suggest, now you need to find and follow another tutorial about how to deploy something. And the real problem is that there are basically 0 tutorials about deploying things that are actually telling you how to set up an application for the real world. Every deployment tutorial hand-waves past a bunch of stuff and is like, oh, we skipped all of the concerns about, running migrations on existing user data or whatever, because this is a tutorial. It's not a real, production-ready environment. And I'm not honestly sure how these tutorials expect devs to learn all of these skills. Maybe just like run into them and have them break and then have to learn, but I would like to talk about it before it has broken. So our hypothetical developer finished a hosting tutorial, has a shiny new application and database, and this is when you kind of like start running up against all of those problems that the tutorial skipped over. Where do your secrets live? Do they live somewhere secure, or did you just check all your secrets into your Git repo because that was easy? Is the database backed up? What happens if the database chokes on something? What happens if there's an exception while you're trying to use the app in production? Do you have any way to debug that? All of those questions. So instead of answering every single one of those possible questions about deployment, this talk is basically a framework for thinking about anything that you might do that touches on production and how it will impact it. So whether this is your first deploy or your 100th production service, this is kind of like the set of problems that you will need to think about and handle every single time. So despite this being something that presumably everyone in here has to deal with at some point, I haven't really been able to find like a solid collection of best practices for deployment in the way that you're able to find a collection of best practices for, style guides or testing or, the other stuff that we spend all of our conference talks arguing about how exactly you should do it to be a good Ruby developer. So I'm trying to get more of the conversation started about us to argue about how you should be doing server-side things and deployments and all of that stuff. So ultimately, the goal of the framework for thinking about production web applications is about confidence. Everything happening in deployment, in operations, in DevOps, in SRE, all of that is about confidence in the application, like your confidence that your code is going to work, your coworkers' confidence that your team's code is going to work, and your customers' confidence that your application is going to like deliver the thing that it's supposed to be doing for the actual customers. Within confidence, I have found it most useful to break everything down into basically 5 sort of bucketed categories of errors, data, speed, security, and lead time. Lead time is the amount of time that it takes for a change to go from when it's committed to when it's live in production. And investing in a shorter lead time can produce absolutely amazing benefits in all of the other areas because you can make changes faster, you can learn from your changes, and then you can make another change that's also faster. We'll talk more about that towards the end. So to start with, let's look at errors. Conceptually, an error is any time that your user isn't able to use your site, right? It could mean that there's your Ruby code through an exception. It could mean that you change the configuration of, your application so that it can't reach the database anymore. It could mean that your data center has burned down and your servers no longer exist. But like all of those things are types of errors from the perspective of your customers. And so with that in mind, how do you know? How do you know if there's an error? How do you know if the thing in production is working or not? So testing is, I guess, maybe the thing that Ruby developers talk about the most out of all the things that I'm going to talk about today. But it is an important way to build confidence in your application, even in production, is having tests. Test it manually, test it automatically, ask random strangers to try it out and tell you if it worked for them. All of those things will save you a lot of debugging time in production, because if you find the bug before it's live in production, it will be much easier to fix. One of the other most popular ways to increase confidence before your production deploy is to have a staging environment and deploy it to staging and test it there. This is like as is probably obvious, like the testing area most commonly gets called staging, but that's not like a universal rule, and the non-testing area usually gets called production, but that's also not a universal rule. And basically by using the staging environment to put the code that you have less confidence in and trying it out there, that increases your confidence. And then with that higher confidence, you can take the code to production. Some platforms, even like Heroku, provide a mechanism to just immediately bump the exact same code straight from staging to production without having to do like an additional deploy step or process, which can sometimes be very handy if your deployment is a hassle. After you're releasing code with your manual and automatic tests to staging and then production, the kinds of things that you probably need to build confidence that your application is working correctly is things like exception reporting and uptime monitoring, where you want to know if your Ruby code is working correctly or if it's throwing exceptions. And once you've deployed and it's no longer on your laptop with a handy, Rails log, how will you know if there was an exception when some random person was just browsing the site and your Ruby code blew up? Well, you need exception monitoring, and you need something that will send you an email or send you a Slack message or whatever when something went wrong. Uptime monitoring, exactly like it sounds, is just automatic requests to your application from other places and creates an alert if the request starts failing, because that means your application isn't there anymore. I suggest starting with honeybadger.io or sentry.io for exception tracking and uptime monitoring. They're both free for a single user, which is really handy if you're starting small. And they both have Slack integrations so that you can get a Slack message or an email or an SMS, if that's what you really want, anytime that there's a Ruby error or a JavaScript error, or if the site stops being reachable from the internet because you misconfigured your, proxy rules or whatever. For anything that's less significant than a full exception, or to help you investigate when an exception does occur, you'll also want to think about what usually gets called instrumentation or observability. And the most basic level here is just seeing the logs, right? It's really hard to investigate if you can't see the logs. And so you need to set something up so that you can see the logs from the Rails app while you're trying to figure out whatever went wrong. Your hosting solution hopefully has the most basic level of here's the logs that your app produced. the more advanced levels of observability, including setting up additional tracking inside Rails, inside your own code. And that kind of tracking can take the form of metrics, which is some numbers or counters where you can like add or, keep track of how many times something happens, or keep track of kind of like what value something had when it did happen. Monitoring that focuses primarily on metrics includes the Prometheus open source tool, Datadog, AppSignal, New Relic, all of the other companies that you've probably heard of because they like sponsoring Ruby conferences, hoping people will use them. And then monitoring finally can also take the form of traces, where your application keeps track of how long each part of when it was running took. So it lets you see when a controller started running, when a database query started, when an HTTP request started, or anything else that happened during the process of running your request. So if you've ever heard of OpenTelemetry, that's what this is about. Honeycomb.io, which is completely different from honeybadger.io. I'm so sorry. Honeycomb is the pioneer of this tracing style of monitoring, and other companies like Sentry and Datadog have now also added the ability to collect and review traces, which can be really helpful for the kind of complicated debugging process where a web request creates a background job that creates an HTTP request that creates a database update, and then it goes wrong there, something like that. So traces are very powerful, and I don't always find Honeycomb's like traces only style easier to understand than just looking at the logs. But there are definitely cases like that really complicated one where having the trace that connects all of those pieces together would have been a total nightmare to figure out in a scenario where all I have is like 3 separate log files and I'm trying to like match up the timestamps and figure out what was going on. So this is way better than the bad old days, trust me. Traces are amazing for that kind of stuff. I'm really glad that we have it as an option now. And then finally, on the topic of errors in production, the open-ended question to ask yourself about errors is, how will I find out when things go wrong? Like do you have a contact form? Do you have a support email? Do you have a Slack channel? Do you have a social media profile? Like how do you hear from your users? Because if you don't, chances are really good that you just won't know that it's completely broken. And there will always be something that you have not correctly figured your exception tracker and your monitoring to like make sure is working correctly. So it is still really important to be able to hear from your actual users, because when none of those automated things work, it's really important to find out, oh yes, this thing that we didn't think about in advance has stopped working. The next category is data, which includes not just the stuff that users have uploaded, like files or whatever, but it also includes anything that you might need when you're recovering from a catastrophic server failure, right? So that could include uploaded files, that could include, the user profile database rows, but you got to think about all of that stuff together if you're thinking about catastrophic data recovery. My favorite example of how this can go wrong is the time that one of GitHub's co-founders ran drop database in a terminal thinking it was a local test terminal. And then they had to restore the entire MySQL database from a backup. And that is when they found out that every Git repo was now out of sync with the database. So by not thinking about the database records and the Git repos as like one thing that worked together, they ended up in this kind of like nightmare scenario where every individual record about the repos and every like actual repo on disk was now like subtly different in exactly what was present and what was missing. And it was a real problem to recover from. Server failures range from the very esoteric, like that GitHub example, through the very mundane, the hard drive in your server died, and that just happens to hardware sometimes, through the other incredibly weird, like a truck hit the data center's power transformer, and now your service is gone, and good luck with that. But they all end up in the same state, whether you dropped the database thinking it was your laptop or whether a truck took care of the data center for you. Your server is gone, and now you need to set up a new server. How bad is this experience going to be? Do you have a copy of the latest code? Do you have a copy of the latest database backup? Do you have a copy of whatever files got uploaded? Can you still get to all of those things easily? So start with the code, make sure that you're deploying to production by pushing from somewhere that isn't your laptop. Set up GitHub Actions to deploy from your main branch or something like that. At least then you know that you have a copy of the code, unless GitHub deletes their production database again, etc. And then make sure that you've handled the database, use a system that automatically takes snapshots, or build something yourself that takes snapshots. For my side projects, I discovered a really great thing, which is that GitHub Actions artifacts have no size limit. And so if you write a GitHub action that connects to your production database and dumps out a copy of it, GitHub doesn't care if that's 25 gigabytes. Artifacts time out after 90 days, which I think is why GitHub is okay with those artifacts being 25 gigabytes. But that means that you could have daily copies of your database for the last 90 days on GitHub's free plan. So knock yourself out. It's great. Having said that, test your backups. There is more than one startup that has completely failed and shut down when they went to restore from their backups and discovered that their backups weren't real and now all of their data was gone. Have more than one backup, preferably one backup per day. Test your backups. Be sure that the backups that you think you have really exist. Definitely make sure to actually restore your backups at least occasionally. Strongly recommend that. Once you have your databases taken care of, make sure that you're looking at all of the files, right? So using a file service like S3 or B2 or Google Cloud Storage can be a huge advantage because those services all provide kind of like a basic guarantee that every file will be stored at least 3 times. And so if a data center does completely disappear and your file's on S3, that doesn't actually matter because S3 will keep 3 copies, and so you'll still have a copy. It is possible, and I sometimes see people recommend that you can run a copy of MinIO in a container and it will be just like S3. And that is maybe true from an API perspective, but that is definitely not true from a redundancy perspective, because if that MinIO container dies, all of those files are gone forever. Please think about backing that up or not using that strategy if those files actually matter to you at all. And then lastly for data, you need to think about how you're going to deal with all of the existing production data that you now have and that is now constantly growing, right? In the whole development situation, anytime you ended up in a weird data state, you would just, DB schema load and magically everything would be unmessed up. And now that your users have records in your database, you cannot do that if you want to still have a product, I guess. And so you need to think about adding, removing, and renaming database columns, which are all things that could potentially break your application entirely now that there's production data. You need to deploy code that can handle the old schema and the new schema at the same time, and then you need another deploy that changes from the old schema to the new schema, and then you need a third deploy that removes the code that dealt with the old schema. So I really recommend the strong migrations gem as a way to kind of add guardrails for yourself once you have actual live production data. Strong migrations will basically say, oh, you wrote a migration that's going to break production. Don't do that. It's very helpful. And then kind of moving on to the next category of things, talking about speed. It is, in fact, possible to get speed out of a Rails app. Don't listen to anyone who tells you otherwise. And in my experience, the biggest reason that Rails apps get slow are actually external API calls, or doing things that don't have pagination built in, or adding hundreds or thousands of accidental N+1 queries to a single web request. Rails may not be the most performant framework in the entire world, but it's still pretty fast and pretty usable. And as Irina was talking about earlier this morning, there's nothing making Rails intrinsically slow as long as you don't fall into any of the actual slowness traps. So having said that, why does the speed of your application matter? And that basically comes down to confidence again. Speed is actually part of confidence, because if your users can see what's happening and it's happening fast, they understand it and they trust that your app is working correctly. If your application takes a long time to respond, if your users lose focus or lose patience, they actually lose confidence that your application is doing what they want it to do, right? Will it ever finish? I don't know. And so that is a very strong reason to use all of the monitoring and observability tools that we just talked about to keep an eye on how long your application is taking to do things. Quick sidetrack, don't use averages. Averages don't exist. They are all lies. Nothing about averages actually tells you anything about what is happening to your users. Track percentiles and think about how many users you have to know what percentiles are acceptable for you. So for example, if you have 10 users per day, the 90th percentile is probably fine to track because that's 9 out of 10 of your users. If you are, I don't know, pick a giant company, GitHub, and you have 100 million users per day, you need to track the 99.9999999th percentile because that's still 10,000 users having a worse experience than that extremely high percentile. And so you need to calibrate what you're tracking to say, like, we want to make sure that no more than, pick a number, 10,000 users per day have a horrible experience, and then you optimize until you reach that goal. Use profiling. When you find something that's slow, your main tool to fight against the slowness is monitoring, like we talked about before, and then profiling. Monitoring can tell you which users experience the slowness. It can tell you what they were trying to do when it was slow. And it might even be able to tell you which SQL query or HTTP call made things so slow. But profiling tells you what code is actually being run when that slow thing is happening and helps you optimize it. The best known profiler for web applications is the rack prof gem, but there are multiple options that can help you and even help you in production by every once in a while, you know, on a tiny percentage of requests running the profiler so that you get an idea of where all of that CPU time is going inside your Ruby code. And outside of carefully optimizing your Ruby code or paying for much, much bigger servers, I also strongly recommend having a content delivery network like Fastly to serve any content that doesn't need to be generated completely fresh on every request. If you have images, if you have downloads, if you have pages shared across users, a CDN is how you make sure that everyone can see all those things quickly. It's especially important if you have users overseas. You know, if you're here and you have users in the US, or if you're in the US and you have users over here, it makes a huge difference to have all of the stuff that doesn't need to be generated live already on the correct side of the ocean. Now that you know about why to keep your application fast, let's talk about security. So there are really two things in any production application that you need to start defending security-wise, and they are kind of like the user data itself, right? The thing that is actually specific to your app, and then the servers that your app is running on, which are not specific to your app. So, you know, the class of attacks that tries to attack user data is like people who want emails or phone numbers or credit cards. But the other type of attack is just about getting access to any server hardware so that they can send spam emails or show ads or mine cryptocurrency or, you know, something like that. And so on the data side of things, the best defense, the safest way to store data is to just not store it. If you can possibly get away with not collecting the data, you never have to think about keeping it safe because you don't actually have a copy of it. If you do need to collect user information, make sure you're only collecting information that you need. And if your users are supplying personal information, especially financial or identity information, make sure that that data is encrypted inside the database so that like a simple database leak won't suddenly reveal all of those copies. It's harder than that, right? They need to have access in multiple ways to be able to decrypt it. It's especially not hard to encrypt like a single column in a model anymore. Rails now has like very effective ways to do that it didn't have in the past. So definitely do that for the specific pieces of data that are sensitive. And the best defense against attackers who want to hijack your servers to do something malicious is to keep all of your libraries updated. And so using a tool like Dependabot or Renovate to apply security fixes and making sure that your application isn't vulnerable to known hacks. That's the best way to keep that in that state. Keep your API tokens encrypted. Don't check them in. Set up monitoring alerts on your server's CPU and disk usage if they're like your dedicated servers. Definitely set up a billing alert for if your usage goes above what you consider normal. There are definitely times in the past where I would have noticed things much faster if I had thought to set up a billing alert in the first place. And ultimately, it's always worth it to have a security policy, even if it's really simple. Provide contact information so that people can tell you about the problems. You don't need a security team and a HackerOne program, but you do need to at least know that things could go wrong and have a plan for how you're going to handle it. Knowing you have backups that can't be deleted by someone who hacks into your server is a really huge advantage here, and another reason why I recommend it. In the final group, so there's a research project called Dora, currently hosted in Google Cloud. It stands for DevOps Research and Assessment, and they've been investigating software teams for many years, basically doing research to figure out what attributes are shared by teams that ship their software quickly and operate it with the lowest number of errors. They've written a book called Accelerate that goes into way more depth about this than I'm going to here. But I'm just going to briefly summarize one specific attribute that I think about while I'm like getting things into production. So that aspect is lead time, which is one of Dora's 4 core metrics in their research. And it's, as I mentioned before, it's the amount of time it takes to go from code being committed to that same code being live in production. So if you can make a change and you can have that change deployed into production in, say, 5 minutes, you're going to have a completely different experience as a developer than if it takes 3 days from the time you make a commit to the time that it's actually live in production, right? The Dora research found that small lead times is one of the biggest predictors of software projects being successful. And so that kind of like main finding ultimately boils down to the conventional wisdom of be really careful and deploy very infrequently with a lot of stress every time is actually very bad for the results. And what is better instead is to deploy constantly all the time so that when things go wrong, you quickly deploy a fix for whatever it was. And if they're still wrong, you quickly deploy another fix for whatever is wrong, instead of spending 2 weeks reverting and hoping that you hit the right thing before the production deploy goes out and you find out that there's a new problem you didn't catch in advance. If you're already operating a larger or slower application in production, my biggest advice is to reduce the size of each deploy and make rolling out each deploy as fast as you can, so that that loop of discover problem, make change, find out if change fixed problem gets as fast as possible. The beginning of your project is by far the easiest time to set up the standard automations that you're going to use for the rest of the project. Set up completely automatic testing and deployment immediately, and then you never have to think about this again. It's great. GitHub Actions, and you can expect new commits to be tested and deployed in like 5 or 10 minutes anytime. That's a really good starting point, especially if you do actually get successful enough that your application and your team starts growing from there. So now that I've filled your head with more ideas than you can probably remember, I'm going to do a quick recap and then briefly discuss the overall strategy to use anytime you're trying to run production applications. So the big concerns are errors, speed, data, security, and lead time. If you use those categories to review changes before you make them, it will help you find out if there's anything that you missed in your plan, basically, right? Like, will the proposed change impact your ability to monitor errors? Will it change how will it impact your backups? Is it a new type of data that you aren't currently backing up? Will it significantly impact your ability to handle user requests quickly? Will it impact your ability to ship changes? So by keeping all of those categories of concern in mind, you are already better prepared to operate a production deployment than maybe the vast majority of software developers. So congratulations. And if the thought of working on these things is interesting or exciting to you, you probably have a bright future in DevOps or maybe SRE. And if the thought of working with all of this set of concerns and problems fills you with sort of an unspeakable dread, I highly recommend sticking to bigger teams where it will be someone else's problem. And kind of having said all of that, if your team needs help with doing the things that we talk about today, I work for Spinel Cooperative at spinel.coop with developers from the core teams of Rails and Hotwire and Bundler and RubyGems. And that is the specific stuff that we help teams with, is like thinking about this and making sure that whatever you've run into that it means that Rails is doing something completely inexplicable, like we've probably run into it before and we can just tell you the answer to whatever that problem is. In the end, will listening to all the advice in this talk mean that your app never goes down? No, I'm sorry. Downtime is just going to happen no matter how prepared you are. And the difference is if you follow this advice and other advice, you will be more prepared. You'll be more prepared to recover from downtime. You'll be more prepared to add protections in the future. And you'll be more prepared to have an application that's able to defend against all of these types of problems that you're going to run into. And ultimately, that's the best any of us can do. And so I wish you all good luck with your future deployments. Thanks.